Today we will start increasing and decreasing nature of functions. The increasing and decreasing and constant functions constant are used to describe the behavior of a function. We go from in the graph for increasing or decreasing we go from left to right. Along its graph. So let us take this is x-axis. We can take here some points. Let us assume x equals to 0. Let us take here x equals to 1. Let us consider x equals to 2 and etc. Let us draw a graph and we see that in this way this is increasing function from left to right, and from here we can see this is decreasing function, and here slightly no change in the curve in up direction or below direction, so we can say it is constant here. And in this way this is up direction, so we can say it is again increasing in nature. So we can observe from this graph, we can observe from the graph function is increasing to the left of x equals to 0. Function is increasing to the left of x equals to 0 and decreasing from x equals to 0 to x equals to 1. X equals to 0 to x equals to 1. The curve is slowly decreasing, and constant from x equals to 1 to x equals to 2, and again the curve is increasing to the right of x equals to 2. This is again increasing here. Now let us consider where the function is strictly increasing and increasing. For strictly increasing on the interval, we can say f is strictly increasing on the given interval. And let us assume, let x1, x2 be the points, and here in this graph we can see this is, let us take x1, this is x2, and this is graph, this is increasing in nature. So this is fx2 and this is fx1, and this is origin, this is x-axis, this is y-axis. Function f is strictly increasing on the interval if x1 less than x2, then fx1 less than fx2, and second, f is strictly decreasing on the interval if x1 less than x2, fx1 greater than fx2. Let us check this strictly decreasing by the graph. So this is point x1, this is origin, this is x2, and let us draw a rough graph here. So this is decreasing and this is fx1, this is fx2. Here x1 is less than x2, fx1 greater than fx2, fx1 is greater than fx2. So function f is decreasing. Now let us take another kind, that is constant. For constant, let us draw, this is point x1, this is x2, and let us assume this is fx2, fx1. Here fx1 equals to fx2 for all x1 and x2. So we can say function f is constant. We have seen increasing, decreasing and constant function here. Now we will check it by an example, and then we will take a theorem. The first derivative test, using first derivative test, let fx equals to x cube. Let us check whether this function is increasing. In nature. So here we have to note another thing, that if we find the derivative of fx, this is single variable, so here we are differentiating ordinary with respect to x, and if f dash x is greater than 0, function is strictly increasing, and if single derivative f dash x is greater than equals to 0, we can say function is increasing. Similarly, if f dash x is less than 0, function is strictly decreasing, and if f dash x less than equals to 0, function is decreasing. By using these things, derivative test, we will check the function is increasing. So here we see that f dash x equals to 3x square. So we can check f dash x is equals to 0 for x equals to 0, and f dash x is greater than 0 if x less than 0, because this is quadratic. So if value of x is less than 0, it will also be positive. So f dash x will be greater than 0. Also f dash x greater than 0 if this condition holds true. So we can see this function, we see that function fx equals to x cube is continuous everywhere. We can check it easily. So function is strictly increasing in minus infinity to 0, and we will use this interval for strictly increasing case. Now let us move another example of strictly increasing and decreasing function. Also note here slope of the function dy dx is greater than 0, function is increasing. Dy dx is less than 0, slope is less than 0, function is decreasing. And dy dx equals to 0, function is constant. So by graphically a tangent slope, we can check function is increasing. In this case it is constant. Let us solve another problem. For the intervals, if we want to find the interval, then fx equals to x square minus 4x plus 6 is, let us check, strictly increasing, second is strictly decreasing. So we can solve easily here. find the first derivative then f dash x equals to 2x minus 4. Next step, put f dash x equals to 0. This implies that 2x minus 4 equals to 0. This implies that x equals to 2. Now on the number line, we will check by number line here. And this function at x equals to 2, value of function is 0. So let us check beyond this x equals to 2 and below this x equals to 2. And a range of the function is not given, so we will consider here plus infinity and minus infinity. At x equals to 2, function is f2 and f dash 2 at x equals to 2 is 0. Now beyond this point x equals to 2, let x is greater than 2. Let us assume, so let us check f dash x for x greater than 2 or at x equals to 3. Let so f dash x greater than 0, we will putting the value here for x equals to 3, which is greater than 2 also. So in this case, function is strictly increasing if x greater than 2. Similarly, we check for x less than 2. So if x less than 2, let x equals to 1. So f dash x equals to 2 into 1 minus 4. This is minus 3 less than 0. So for x less than minus 2, let us take x equals to 1. F dash x is less than 0. This implies that fx is strictly decreasing if x less than 2. Here x equals to 1 we have supposed. So this is positive and here we will draw the graph. This is negative. We can say positive John and negative John. So strictly increasing function if we can consider the open interval 2 to infinity. We have already seen that for strictly increasing we will use this open interval, and similarly strictly decreasing in the interval minus infinity to 2, and we will consider here this is open interval. This is our answer for increasing and decreasing in nature. And for our this line interval we can write also in this way. Function f is strictly increasing in 2 to infinity open interval and strictly decreasing in this interval. This is our basic criteria for solving and finding the interval where the function is increasing, decreasing, or strictly increasing or strictly decreasing.